hey, look at that backdrop. It's not too bad. So I'm halfway on my run, and I thought I'd use this excuse to record my next video. I'm feeling fit. It's proper hot outside. The temperature's like nearly 30 degrees in London. Oh, look, there's someone running there. I'll catch up to him. Don't worry about that. Thought I'd use this normal experience going from my normal weekly run just to give a quick update on where we are with the project. So let me just show you quickly where we are. We've finally got a position in relation to the CCTV survey that we carried out. We've hired in a professional in the end, and that made just more logical sense. So this is what the resultant drawings look like before and after. So just to give you a bit of context, this is the schema that we're working with at the moment. And for those that are new to the channel and those that are still watching the channel but don't have a clue, maybe I haven't given enough context or haven't been clear, I'm just using this as an opportunity to just reset in relation to where we are at the moment and how far we've got through all the challenges we've had. So what you see in red, all the red lines, these are all the drainage runs that we believed we had from a before state. Now this corresponds with manhole 1 and manhole 2. The flow of sewage comes from all of these properties across the left-hand side of the image that you can't see, including this neighboring property here. And the flow of sewage comes down through manhole 2, manhole 1, all the way out to the front garden, and there's another manhole at the front garden. Now the height from which the drainage exists at manhole 2 is higher than the position on the actual road itself. And also call out the fact that these manholes are 6 foot deep and deeper. So naturally this is going to be the highest point, because obviously the drainage has to flow in a downward direction to exit onto the main road. The manhole that exists here will be at a much lower depth than obviously the manhole we've got that exists here, which is M2. And as you can see, if you cross-reference the pictures with the illustration, you can see the drainage runs from inside, a picture taken from inside both manholes, and the orientation of both of these manholes is correct. So as you can see, manhole 1 is a straight run. Now these two cast iron pipes serve the private drainage system to the house at the moment. So this one on the left serves the first floor bathroom. This one on the right serves the ground floor bathroom. So don't worry too much about those two cast iron pipes. They're not really of any concern. Manhole 2, again, the drainage comes in from the neighboring properties all the way through this channel here, all the way through manhole 1, and then out the front into manhole on the main road. The question mark we had was this one here, this angle that comes off. We didn't know if it was in use. We didn't have a clue what it was for. So just so you guys are clear here, this little pipe here that you can see that's poking out, it's actually got a hole at the bottom, and essentially it currently serves the kitchen. So any water that comes up from the kitchen tap will go straight into the manhole at the moment. Now this run here, you can see it goes off at an angle. It's about a 45-degree angle, and that's what this design assumes. This was before we did our CCTV and before we kind of understood as to where it was going, because the challenge we had was this manhole is very deep. It doesn't look it from the picture, but it's about 6 foot deep. So we're in a position where we didn't 100% know whether this run was going at a 45-degree angle or a 90-degree angle. If it was going at a 45-degree angle, it would mean that the design that the architect proposes is going to be different to if it's going at a 45-degree angle. And just to be clear, what we're trying to achieve here is manhole 1 and manhole 2 are not allowed under any circumstances to be built within the trajectory of the new house. So in the new house's proposed design, this angle is around here is where the house is going to finish. So what you'd end up having is 2 manholes in your front kitchen, which isn't allowed by Thames Water. So the idea is, and why we're doing this, is to come up with a design to potentially move these manholes, or move a manhole outside the scope of the house. So what we wanted to be was in a position to either move one or both manholes outside that property, just to comply with building regulations and to comply with Thames Water's build over agreement that we got signed off. So just to give you a bit of context there. So the key ask was work out whether we're going on a straight run or whether we're going at a 45-degree angle, because that will determine the architect's design. We didn't want the architect to go away, make an assumption that it's a 45-degree angle based on the fact that it's currently 45 degrees, and then get it approved provisionally, get his design provisionally approved by building control, and then start the digging and then realize actually it's a 90-degree angle, because it would mean more rework for the architect. And again, it would end up costing us more money and it would end up costing us more time. So that's just not logical to do that. So I hope that makes sense. If you've got any questions about it, let me know. I'm kind of a drainage expert now. So what we did was we did a CCTV survey finally, and we established that it is actually a straight run all the way through the neighbour's property and beyond. I think it goes up about 10 meters and there's another manhole somewhere around here. But we're only concerned about our property boundary wall, which is around here. And yeah, we confirmed that it's a 90-degree angle. So it kind of goes like this. And then it stops, and then it doesn't stop. It just junctions off. And you'll see that in the next image I'm about to show you. This one, we can kind of get rid of now. We know that's not, that it's not going that way. So this will just be scrubbed off on the next drawing. So now just to give you a bit more context, what this is a draft drawing of the architect's proposed design, assuming when I mentioned earlier, we're looking at a 45-degree angle bend on the drainage pipe, and this was his proposed design on that basis. So he did put together a draft design because we were potentially going to go down that route and just make an assumption, but good thing we didn't, and you'll find out why in a second when I share the next slide, or screen should I say. So just to give you an understanding of this kind of level of design, it's pretty much the same principle. So you've got the kitchen here, it's just not labeled because it's just draft. So you've got the kitchen here, the garage is here, and that's the main drainage run coming in from the main road, bending to the left-hand side to serve all the neighbours on this side of the road. But obviously the drainage flow, in terms of which way the direction the sewage and waste is going, is out towards the main road. And this is the boundary here, and the other boundary is there for both neighbour 1 and neighbour 2. These little square dots are the existing drainage manholes, which you see. These are the existing drainage manholes which you've seen on the last. These are the existing drainage manholes which you've seen on the last picture. What he's done is he's making an assumption that the drainage flow comes in, and what Thames Water in their build over agreement have said, we are able to rip out that manhole and replace it with a straight run pipe, and then we rip out the second manhole and we replace it with a bend, a Y bend, which will bend right to the left, and it will go straight. And this T is the foundation that is going to serve the new house. So this will be where your patio doors are. This will also on house 1, and this will be where your patio doors are on house 2. He's put it on here just so just to explain how it ties in with the drainage situation. And what this is the equivalent on the last picture where I showed you the cast iron pipes which fed the bathroom on the ground floor and the bathroom on the first floor. Now, this is at a surface. This is his proposed design, assuming you've got a 45-degree angle, but this is just draft, just bear that in mind. So this is the surface manhole, and it allows anybody to be able to rod and clean out pipes that will be serving the proposed house when it's built eventually. So this is really simple to put in and install because it's only 450 mil underground. Then those two will feed into the 6 foot deep manhole. I mentioned earlier that we had two manholes existing and that we're either going to have one outside or two outside based on the proposed design. The architects decided to go ahead with a 6 foot deep manhole outside, and this assuming we're running out here at a 45-degree angle bend, but we didn't know at this stage, so he just put this together to show me his potential, some potential idea for what he thought we might need to do. Okay, so I hope that makes sense. I think I've explained everything on there. Again, if you've got any questions on this part, pop it in the comments and I'll do my best to answer it. And what he's done, which is different to the original design, is what he suggested. If it was a 45-degree angle, all of this drainage run here, which would serve all the properties across this side, they would all feed into the main manhole, which is 6 foot deep, and then they'll feed out straight to the front to the main road, and all the properties on the left hand side here will feed into the same pipe all the way out through to the main road. So that hopefully we would have sent to building control. They would have provisionally said, yep, that looks right, that makes sense, crack on with the actual physical build, and we'd be good to go. Now, the problem with it is that if now, for example, it turned out this was actually a straight run and didn't go at 45-degree angle, his whole design would completely change to this. Hopefully you can see that all right. But essentially it's the same drawing, but because we confirmed with the CCTV survey that it goes off at a 90-degree angle, we've still got the same predicament. We still need to put a manhole outside, a 6 foot deep manhole outside, and a surface manhole. But it has changed the design in the sense that, can you see how now the drainage run goes underneath the foundations twice, whereas in the previous slide, the drainage only went under the foundations once, which was around here, and then it kind of went out that way. Now, the challenge we've got with this approach, and the challenge we've got with the fact that now we've done our CCTV survey and it is a right angle, is his proposed design for the drainage system means that, as I just mentioned a minute ago, your pipes are having to go under foundations twice. So there's going to be a lot of weight on these foundations. If as I said, the manholes are 6 foot deep, and the foundation depth, so that's where all the concrete's going to get poured, is about 200 mil underneath the actual drainage pipe itself. So you can imagine 6 foot deep foundations around this area, around these areas here. 6 foot deep foundations under these 6 foot deep foundations full of concrete are going to put pressure on these pipes. So now this is where the architect earns his money, in the sense that he has to come up with a design along with the structural engineer to work out how we support the pipe, because that's all Thames Water care about. If, for example, a neighbour's flushing their toilet and the drainage is coming through, underneath our existing house or under our new house, as you can see, it sits within the boundary, then if there's a problem at this part, say for example, the foundation collapses and breaks the drainage system, you're going to get a pile up of sewage here. And when Thames Water come out to try and fix it, it's like, well, how are we supposed to fix this? We're having to now, resolve foundational issues with the property. This is why it's so important to make sure that your drainage is done correctly, to a correct design, so that people are accountable for if anything does go wrong. So architect's job is to come up with a design that supports, the infrastructure that's being recommended by himself. So that's what we're waiting on now. He has put this draft together to say what he's going to be kind of doing, and then he's going to create an annotated drawing of this in more detail, which I'll show you guys on the next episode when hopefully it comes out this week. And then we're in a position where, again, this design is slightly different in the sense that it bends around and feed the main sewer. So hopefully this gives you a nice picture of the position. And one thing I forgot to mention was when we did the CCTV survey, it was a straight run. And then under our existing kitchen, you've got a turn. So it turns off left twice. You can see if you could just about make those faint lines out. So these are 2 additional pipes that bend off to the left or junction off to the left, which probably serve the neighbor's kitchen or bathroom or whatever. And then further down you go, again, it tees off, it junctions. The further down you go, it junctions off again and again and again. And then there's another manhole further down the road, which you can see. So hopefully that gives you guys a good understanding and a contextual approach to what's going on here. And that hopefully I've explained it in a way that makes sense to people of all skills and abilities to help you with your drainage situation. Very important part. And as I said, everything's going to be built on top of this. So you need to make sure that it's done correctly. Because you don't ever want to be in a position where you need to dig it all up again. You just want to just do it once and that's it. Leave it for the next 100 years. So yeah, that's drainage in a nutshell. And I've learned all of this just by asking questions, just by speaking to people, listening, learning, and doing a bit of research. So I found that on YouTube, there's not that much content on drainage, and it's usually the experts just giving a really high level view, and no one really goes into detail like this. So hopefully what I've said makes sense and can hopefully help you with your drainage situation. Now we're finally in a position where architect has now got everything he needs to create a draft design, for which he's already done, as you've just seen. And now we're waiting for him to create a more mock-up version, so with text, annotations. And then next week, we're going to have a call with the building control and the architect to just run through provisionally the design that the architects put forward that you've just seen. And then we should be in a perfect position. We're finally going to be in a position where we will have a final drawing with annotations, with all the materials we need, with the construction elements in there as well, built in, whether it's going to be concrete, whether it's going to be brick. And then we should be in a position where we can actually physically start the work and price up how much it's going to cost. So yeah, that's where we are at the moment, guys. Quick short update this week. Hopefully you should be able to share more next week as to what's going on. And I can show you what the actual final drawings look like and how much they kind of will cost from a ballpark figure. I'm getting much better at recording these videos. So yeah, I'll just quickly show you the views again. My favorite park, Lloyd Park, which I mentioned in my first video. I come here on my weekly runs. I've got 2 routes. One's Lloyd Park and one's like a street run around right near where I live. But yeah, it's all good. So don't forget to like and subscribe. Stay tuned next week. I'll be giving more of a comprehensive update. Hopefully by then we should have the detailed drawings and I can go through all of those just to show you exactly what we're doing and how it's working, so that when you eventually do your drainage, you can kind of compare and contrast and see if what you're getting also makes sense. Yeah, hopefully you've learned something today, and I'll see you guys on the next episode next week. Until then, peace.